Okay, so in 2.3, we worked with set operations and event diagrams with 2 sets. So now the only difference is we're going to work with 3 sets. And so here we have the universal set, which in the last video actually should have that curly little tail there, because I said that the universal set, not to confuse with the union, was going to have this little tail. So I apologize about that. I didn't get any emails or corrections to give anybody extra credit about that, but I did want to make sure, again, to avoid any confusion. So similarly to 2.3, right, with 2 sets, we determined we determined set operations, right, with the intersection and union. So let's go ahead and do that with 3 sets. So example 1, let's just call this part A, because I'm going to do 3 parts. And so we have set A, right, which is obviously given above, union, okay, not universal set, and I'm going to union it with this set, the intersection of B and C. Okay, so think of this as 3 parts. So my first part is, or steps if you want to think about it, if you like steps. Step 1 is, well, let's determine that set A, which is, this is actually pretty easy because there's no complement, it's just A. Whoops, and this should be blue. And this guy we're going to compute, that's going to be step 2. And then let's just choose purple, since pink and blue make purple. And then we're finally going to take the union of those 2 sets, and that's going to be my final step 3. Okay, so set A, well, set A is, again, it's pretty much what we have right here, right? Set A is just 1, 2, 3, 4, 5, right? The first 5 natural numbers. Okay, so that was pretty easy. Step 2, so step 1, okay, step 2 is I want to compute B, the intersection of B and C. And let me get my white here. So the intersection of B and C. Again, if you're familiar with set theory, again, I encourage you to write all your steps and write out your sets. It's only going to help you, especially with partial credit, on your ICA, on your entrance and exit card and exam. So it's better to be safe than sorry. So let's go ahead and write these sets out. Okay, so I have B. So set B is 1, 2, 3, 6, and 8. Okay, and I'm going to intersect it with set C, and set C is 2, 3, 4, 6, and 7. And that's a 7. Again, on your exam, which is going to be next Tuesday, just for writing this part, okay, that's partial credit. That's going to give me, 1 or 2 points, because that tells me that you know what this set is, you know what this set is, opposed to skipping the step. Okay, so what does, right, this operation mean? Well, that means what do they have in common, this set and this set? Well, what do they have in common? It looks like 2, right, 2, 3, and 6, right? So there's 3 elements in this set, and right, its cardinality is 3. Okay, so that's step 2. Step 3 is the union, right? The union of set A and set B that we just found. So now let's write out let's make this a little bit smaller so we can see everything. Okay, so we have A, and let me get my pink here again. So I have A, which is, well, let me just go ahead and write everything out. So A union B, which is going to be this guy. And, well, let me just go ahead and put parentheses around that, and this guy actually is going to be purple. Okay, so what is my A? Well, that was the easiest one. A was 1, 2, 3, 4, 5. Okay, the union And B, well, what it was B? Well, B was right here, right? It was 2, 3, and 6. And okay, so what do these, what is the union of these two elements? Okay, now I'm going to write the definition just because it's very important to understand what the definition means of a union and intersection. So recall that the union, right, if I just say A union B, okay, so again, just recall, is in set builder notation the set of all elements, right, in your set such that that element is in A, or that element could be in B. And we'll might as well, let's just write the intersection. I should have written it above, but it's, again, it's good to have together. So again, that's the set of all x such that x lives in A and x also lives in B, right? This is where, whoops, this is the intersection, right? That middle piece of the two circles, or in this case, three circles, which we'll do in a bit. But this one's or, there's a big difference. So here, I want you to understand, so from here, the answer to this is, okay, so we open our brace, and it's all the elements, let me get my pointer, all the elements, okay, such that x lives in A, right, because I have the union, x lives in A, okay, so there's my A, so I'm going to write out, might as well use pink here, 1, 2, 3, 4, 5. Okay, so the set of all elements that live in A, so far so good, or, okay, or the elements could live in B, okay, so what is, well, I mean, this is our B in this case, right? So this is our B. And so I can write in this set, right, because it's or, I can write 2, 3, and 6. Now, if I write 2, 3, and 6, and let me get my white here, okay. Now, what's wrong with this set? Not, I mean, nothing's technically wrong, but you know, if you have this set and you say, oh, I have numbers 1, 2, 3, 4, 5, 2, 3, 6. Well, I mean, we're repeating 2 and 2. I mean, if I have the number 2 and I have the number 2, you're being redundant, so you don't have to include the repetition. Similarly with 3, right, you don't have to write the 3 again. So your final answer is 1, 2, 3, 4, 5, and 6. Okay, so it's the first 6 natural numbers. And one thing I want to just point out before I go on to the next video is, so here, right, okay, so this is the general definition, right, of two sets, right, the union of two sets, the intersection of two sets, right? Here's there's a set, there's another set that we computed, and then we have the union. So our B, right, this is general B, but in our case, our specific case, this was our intersection of B and C for the union. Okay, so hopefully that helps. If it doesn't, please let me know, and I will try my best to maybe explain it differently.